Right now, while you're lying here, space itself is expanding. Not the stars moving outward through existing space, but the fabric of space itself, slowly stretching. Every galaxy is being carried apart from every other galaxy by that gentle, ongoing expansion. It has been happening for about 13.8 billion years, and it is happening right now as you settle in and let your eyes close. You don't need to feel it. You don't need to understand it fully. It's just a fact about the place you live in, that it is always, very quietly, getting a little larger. Welcome back to Midnight Lab. Tonight's story is about how the universe grew from an unimaginably hot, dense beginning to the vast, quiet space you're floating in right now. It's a long story, a very long one. And that's exactly why it makes a good bedtime story. You don't have to follow every step. You can let parts blur and drift past. If you're still awake by the end, that's fine. If you're asleep before we get to chapter 3, that's fine too. For now, just notice the weight of your body, where it rests. The room around you, the quiet, and the fact that outside, above whatever ceiling is over your head, the universe is gently stretching in every direction without any help from you. This is the part where honesty is important. When people ask, what came before the Big Bang? The most truthful answer from physics is, we don't know. Our equations and models describe what happened from a fraction of a second after the beginning. Before that, the physics we have stops working cleanly. Some scientists think there may have been a previous state of some kind. Others think time itself may have begun with the Big Bang, making before a word that doesn't quite apply. You don't have to resolve any of that tonight. Nobody has. And there's something genuinely relaxing about a question that even the smartest people leave open. You're not behind on this one. The universe keeps its oldest secrets well, and we're still learning how to ask the right questions. So for tonight, let's simply begin where our story can actually start at the earliest moment we can describe. A state of unimaginable heat and density where everything that would ever exist was compressed into something incomprehensibly small. Not a point in empty space. Not an explosion in a room. Just the beginning of everything, including space itself. You don't have to picture it. Nobody really can. Just know that it happened, and that you are one of its very distant, very improbable outcomes. And the very first fractions of a second, the universe expanded at a rate we struggle to describe. This early phase is sometimes called inflation, a period of extremely rapid expansion that stretched the universe from something microscopic to something enormous in an almost unimaginably short time. After inflation slowed, the universe was still incredibly hot and dense, filled with a sea of energy, particles and antiparticles, colliding constantly. In those early moments, matter and antimatter were being created and destroyed continuously. By some small imbalance, we still don't fully understand, slightly more matter than antimatter survived. That tiny excess is everything you see today, every star, every planet, every atom in your body. You are the result of a small imbalance in the first seconds of the universe. You don't have to feel significant about that if you don't want to. It's just what happened. And somehow, 13.8 billion years later, here you are, lying quietly, listening to someone. Describe it. The universe was very busy in its first moments. You are allowed to be much less busy right now. As the universe expanded, it cooled. This is a simple relationship. The more space spreads out, the lower the average temperature. In the first few minutes, the temperature dropped, enough for protons and neutrons to begin sticking together, forming the nuclei of simple atoms, mostly hydrogen and helium. This process is called Big Bang nucleosynthesis. You don't need to remember the name. What matters is this. In those first minutes, the universe quietly made most of the hydrogen that exists today. The hydrogen in the water you drank today, the hydrogen in your cells, was forged in the first few minutes of the universe's existence. After nucleosynthesis, the universe was still too hot for electrons to attach to those nuclei. Space was filled with a dense, glowing plasma. Opaque, like fog so thick, light couldn't travel in a straight line. Everything was bright, but nothing was visible. The universe was a warm, glowing, opaque sea of energy and particles expanding steadily, cooling slowly. If you were somehow there, you would see nothing but a bright, uniform glow in every direction. It was, in its own way, very calm. About 380,000 years after the Big Bang, something changed. The universe had cooled enough that electrons could finally join with atomic nuclei. For the first time, neutral atoms existed. And with neutral atoms, the fog cleared. Light was suddenly free to travel in straight lines across space. That moment is sometimes called the surface of the last scattering. The light released in that moment is still traveling today. We can detect it. It reaches us from every direction, stretched by the expansion of space into microwaves, rather than visible light. We call it the cosmic microwave background. It is the oldest light in the universe, a faint, almost uniform glow. In every direction, the afterglow of a moment. 380,000 years after everything began. If you had the right instruments, you could detect it. Right now, in this room, it fills all of space. It surrounds you. Not in a way you need to feel anxious about. It's completely harmless, just ancient light that has been traveling for almost 14 billion years and happens to be here, right now, along with you. That's worth sitting with for just a moment. The oldest light in existence is in the room with you tonight. After the cosmic microwave background was released, the universe entered a long, quiet period. There were no stars yet, no galaxies, no light sources of any kind. Just hydrogen and helium gas, very slowly drifting, very slowly clumping, under the pull of gravity. Astronomers call this period the cosmic dark ages. It lasted hundreds of millions of years. If you could somehow be there, floating in that space, you would see nothing. Complete darkness in every direction. No warmth, no glow, no flicker. Just cold gas, drifting very slowly in an expanding universe. It sounds like it should be unsettling, but I find something deeply restful about it. A universe That is simply waiting. Not in a hurry. Not producing anything yet. Just letting gravity do its quiet, patient work. The dark ages lasted for what feels like forever on human timescales. But the universe was fine. It didn't need light to keep going. Sometimes rest looks like nothing happening. That doesn't mean nothing is changing. Below the surface, things were slowly gathering, getting ready for something. After hundreds of millions of dark, quiet years, the first stars began to form. Dense pockets of gas had been gathering under gravity all that time, and some of them finally became dense enough and hot enough to ignite fusion. The very first stars were likely very different from the stars we see today. They were probably much more massive, much hotter, burning blue-white, and intensely bright. They didn't live long. Heavy and hot, they burned through their fuel in millions of years, rather than billions. But in their short lives, they changed everything. Their radiation began to ionize the surrounding hydrogen gas, slowly clearing the fog that had hung around since the universe's early days. And when they died, they scattered heavier elements into space. For the first time, carbon, oxygen, nitrogen, elements that didn't exist before those first stars, lived and died. After a long, deep silence, the universe had light again. And with that light came all the complexity that would eventually lead to planets, oceans, and the room you're resting in now. You don't need to trace every step of that path tonight. It's enough to know that the darkness ended as it tends to. As more and more stars formed, they didn't just scatter randomly. Gravity drew them into groups. Small groups became larger ones. Clouds merged, clusters formed, and gradually, the first galaxies appeared. The early galaxies looked different from the ones we see nearby today. Smaller, more irregular, more actively forming stars. Over billions of years, they collided and merged with each other, growing larger. Some developed the graceful spiral shapes we recognize today. Others became smooth, rounded ellipticals, all of them embedded in halos of dark matter, as we talked about in another episode. The universe was becoming structured. Not random scattered stars, but organized collections. Galaxies within clusters, clusters along filaments, filaments forming a web that stretches across the observable universe. It took billions of years to build that structure. And once built, it didn't need any maintenance. It just exists, holding itself together through gravity without asking anything of the stars and planets inside it, including you. For most of the universe's history, the expansion was slowing down. Gravity, always pulling inward, was putting the brakes on the outward expansion from the Big Bang. Astronomers expected that expansion would keep slowing, possibly even reversing one day. But in 1998, two independent research teams were measuring how distant supernovae appeared in the sky. They found something they didn't expect. The expansion of the universe was not slowing down, it was speeding up. Distant galaxies were moving away, faster than they should have been if gravity were the only force at play. Something else was pushing space apart. We call it dark energy. Not because we understand it, but because we need a name for whatever is causing this accelerated expansion. Dark energy makes up roughly 2/3 of the universe's total energy content. And we genuinely do not know what it is. But here is the thing worth noting tonight. Dark energy works on scales so enormous that it has no effect on you, your body, your planet, or even your galaxy. It only matters across distances so vast they have no meaning in your daily life. So you can rest without worrying that dark energy is doing anything to you. It is simply quietly pushing at the very edges of the observable universe, far beyond anything you need to think about tonight. About 9 billion years after the Big Bang, in a somewhat ordinary region of a somewhat ordinary galaxy, a cloud of gas and dust began to collapse. It had been enriched by generations of stars that had lived and died before it. Heavy elements built in stellar cores and scattered by supernovae were part of its makeup. From that collapse, our sun formed. Around it, a disk of leftover material slowly gathered into planets. One of those planets formed at just the right distance to hold liquid water on its surface. Over another 4.5 billion years, that planet changed. Oceans formed. Chemistry became biology. Single cells became complexity. Complexity became eyes, ears, minds, and eventually a species that looked up and started asking questions. That's us. We are the universe, looking at itself, made of old star material, sitting on a planet, formed from a collapsed cloud inside a galaxy. That is itself the product of billions of years of merging and growing. You don't need to feel profound about that if you don't want to. But if it gives you even a small sense of being part of something much larger and much older than your daily concerns, you're welcome to rest in that. Your worries are real. They matter on human timescales. But the universe has been building toward you for 13.8 billion years, and it did not do that so you could lie awake, staring at the ceiling. Let's take a moment to think about how large all of this is. Not to overwhelm you, but because, for some people, the sheer size of the universe is actually calming. The sun is about 150 million kilometers from Earth. Light, traveling at 300,000 kilometers per second, takes about 8 minutes to cover that distance. The nearest star, beyond our sun, is about 4 light years away. That means the light we see from it tonight left that star 4 years ago. Our galaxy, the Milky Way, is about 100,000 light years across. The nearest large galaxy, Andromeda, is about 2.5 million light years away. The observable universe, the part we can in principle see, stretches about 46 billion light years in every direction. These numbers are genuinely meaningless to the human mind. And that's the point. When something is too large to worry about, you are quietly given permission to let it go. your concerns about tomorrow or last week or that conversation, you keep replaying. They exist in a very small corner of an almost infinitely large place. That doesn't make them unimportant, but it does make them manageable, small enough to set down for one night. The universe doesn't need you to solve anything before you sleep. It will still be the same size. In the morning, there's a boundary around us in every direction called the cosmic horizon. It's not a wall. It's not a surface. It's simply the distance beyond which light has not had enough time to reach us since the universe began. Beyond that horizon, there is almost certainly more universe, more galaxies, more stars, more space stretching on for distances we cannot measure from here. We will never see it. Not because of any barrier, but simply because the universe is not old enough yet for that light to have arrived. And because space is expanding, some of that light will never arrive. There are galaxies that are already permanently beyond our reach, not just to visit, but even to observe. That is one of the quieter and more profound truths in all of cosmology. The universe is larger than what we can ever know, and somehow that feels freeing. We don't have to know everything. We were never going to. There is an edge to what is knowable, and it was set before any of us arrived. You are not behind on anything. The universe has already decided what we can and cannot see, and no amount of thinking tonight is going to change that. Looking ahead to the far future of the universe can sound frightening. Heat death, the Big Rip, an empty, cold void. But these things exist on timescales so enormous, they have no real meaning for anything alive today. The sun has about 5 billion years left in its life. Stars will continue forming in galaxies for trillions of years. The last small red dwarf stars may burn quietly for 10 trillion years or more. That is a number with 12 zeros. After stars fade, black holes will remain for even longer, slowly evaporating over inconceivable stretches of time. And after that, a universe of maximum entropy, quiet, dark, spread thin across an almost infinite space. But none of that touches you. Not in your lifetime, not in the lifetime of anything you have ever known. You live in the universe's middle age, still bright, still active, still full of stars and galaxies and worlds where things are happening. The long quiet is so far away. It exists in a different kind of time than the one you live in. Tonight, the universe is warm and full of light. You are here in one of its best chapters. Let's come back a little closer now, back from the edges of the observable universe, back from the first seconds of time, back through billions of years of cooling and clustering and star formation, back through the formation of our galaxy, our solar system, our planet, all the way back to this room, this moment, this breath. You are the endpoint of an almost incomprehensible chain of events. Every atom in your body has a history that stretches back nearly 14 billion years. The hydrogen in your cells was made in the first minutes of the universe. The heavier elements were forged in stars that lived and died before our sun was born. You are not separate from the universe's story. You are a part of it. That has become aware of itself. And right now, that part of the universe is tired and needs to sleep. That is not a small thing. Rest is part of every natural cycle we know of, from the rotation of planets to the pulse of stars to the slow rhythm of your own heartbeat. The universe built rest into it, including you. So let your shoulders drop a little more. Let your jaw unclench if it needs to. Let your breathing find whatever rhythm feels natural. You've traveled 13.8 billion years tonight in your mind. That's enough for one evening. The universe is still expanding right now. Quietly, in every direction, space is growing, a tiny fraction larger with each passing second. Galaxies are drifting apart from each other, across distances that will never be crossed. Stars are burning in their patient, steady way, the same way they were last night and the night before that. Somewhere out there, a protostar is gathering its first warmth inside a dark cloud. Somewhere else, a white dwarf is cooling quietly. In the dark, its long life done. And here, in this room, in this small, warm corner of the universe, you are breathing and resting and letting go of the day. That is the whole story. From the first fractions of the first second to this moment, everything that happened led to this room, this night, this breath. You don't have to carry it. You don't have to understand it. You don't have to do anything with it at all. You can simply be one small, warm, living part of a 13.8 billion-year-old story that is still going. And let sleep come whenever it's ready. It always is, eventually. Thank you for being here at Midnight Lab tonight. Rest well. The universe will keep doing what it does while you sleep. Good night.